so I can have the animation on my PowerPoint. Let's see here. Okay, now, so let's get ready to start. Today's session, I am going to cover systems of equations. I believe this is like chapter 6. Chapter 6, they cover by graphing, by substitution, elimination method, application problems with 2 variables, and then larger systems of linear equations, which are with 3 variables. So these are the topics that I'm going to cover today. Okay, now these are solutions of systems of linear equations. Here I have 2 questions here. Determine whether the given ordered list of numbers is a solution of the systems of equations. For this to be true, this point must make these 2 equations true. Okay, we're going to plug in -1 for x and 3 for y, right? That's my x and that's my y. So here we go. I'm going to plug them in on both. When I teach this course, I like to call this equation 1, equation 2. This way, it'll be shorter. I'll just say 1 or 2. So first, I'm going to go to equation number 1, and I'm going to plug in -1 and 3. Right? My x is -1, and my y is 3. Now we get to simplify. So we have -2 plus 3. So 1 equals 1. So this is true. Okay, if this was false, then you stop there. So this point would have not been a solution. Okay, but since it's true, we continue. So it has to be true also for number 2. I mean, for equation 2, for this point, -1, 3 to be a solution to the system. So we do the same thing. We're going to plug in -1 for the x and 3 for the y. Now we simplify, so we got 3 plus 6. So 9 equals 9, right? So this one checks. Since the order pair, -1, 3 makes both equations true, then the order pair is a solution. So this one, number 1, is a solution. Now we're going to repeat the same process for number 2, but now we have a different point. So this point is 2, -0.5. Okay, again, equation 1, equation 2. So I'm going to repeat the process as the first example. So, but this time x is 2 and y is -0.5. So this becomes 1 minus 4 equals -3, right? So this is true. So we continue to equation number 2. And again, we repeat the same process. So I'm going to plug in 2 for x and -0.5 for y. So here, if we subtract 2 minus 2.5, it's going to give us -0.5. So this is not equal, right? -0.5 does not equal to -5. So that means that this is not a solution. And again, since the order pair 2 with -0.5 does not make both equations true, then the order pair is not a solution. So number 1 is a solution, and number 2, not a solution. Okay, now this is systems of 2 linear equations and 2 variables. This here, guys, means intersection, right? This means that this point here is a solution. And for example, for B part, you have a line on top of a line, so this is infinite solutions. On number 3, the lines are parallel, so that means there's no solution. Okay, but each one of these lines has a name for them. Okay, for example, graphic line. So here, one solution, guys, you can have x equals to a or y equals to b. Once you begin solving it, right, you can get x equals to a number or y equals to a number. That means that you can have one solution. And this is called, for example, if you get like x equals 3 or y equals -2, then that means that that is going to be one solution. On B part, it means infinite solutions, like a equals a. What does that mean? It means like let a be a real number. In math, guys, they use a lot of variables or letters to represent, like real numbers. So, for example, here, it can be something like 3 equals 3 or 0 equals 0. So that means that this is true, right? So that means there's going to be infinite solutions. There's not going to be a y, an x or a y. At the end, you're going to get something like a number equals to that same number. That means infinite solutions. And no solution means like a equals b, right? Let a and b be real numbers. But like, for example, 3 equals 4. You see, no solution because 3 does not equal 4. So here, guys, also, there's no x or no y. You might be thinking, what does it mean, Mr. Isasi, by this? Okay, right now I'm gonna refer you back to figure B and C. Okay, this is called consistent independent system. Every time you have a solution, it's called consistent. But this one's independent, doesn't depend on nothing, guys. Like for example, for B, that one is going to be consistent dependent. Okay, and when you have no solution, it is called inconsistent. These are different names. For each one of these. For example, one solution, consistent and dependent. Infinite solutions, consistent, dependent, and no solution, it means inconsistent system. Okay, now by graphing, they don't really emphasize how to graph in this section here. Okay, but I like to do this. I like to graph it anyway because if you take the next course 1325, you need to know how to graph. Okay, so let's graph this one. So this can be a review of graphing. For example, equation 1, we have y equals to 3x minus 6. So here, guys, we know that the slope is 3 over 1, right? Because this is my slope and that's my y-intercept. My b equals -6, which is my y-intercept equals 0, -6. So to graph it, the b or the y-intercept is my starting point. So this is my starting point, 0, -6. So my slope means that I'm going to go up 3 and 1 across, right? Because they're both positive. So from 0, -6, I'm going to go up 1, 2, 3, and 1 across. There's a point. And you only need 2 points to draw the line. There's your line. So this line belongs to equation number 1, y equals to 3x minus 6. Now, equation 2 is not in the form of y equals to mx plus b. So I have to solve for y and put it in the slope-intercept form. Okay, so I'm going to add 5x to both sides. So we get -2y equals to 5x minus 10. Now I divide every term by -2. So here we got 5 divided by -2 and -10 divided by -2 gives us 5. So now here, guys, my slope is -5 over 2. And my b is 5, which the y-intercept is 0, 5. So this is my starting point. So I'm going to start at 0, 5, right? 0, 5 is up here. There's your point, 0, 5. Now the slope is negative, right? I can go down 5 and 2 to the right, or I can go 5 up and 2 to the left. Most of the times, for example, here I cannot go 5 up, right? Because the graph only goes to 6. So here I must go down 5, 1, 2, 3, 4, 5, and 2 across. There's a point there. So we connect the points, and that's my line. So this is my solution. It's going to be 2, 0. The point where both lines intersect is a solution, which is 2, 0. Okay. So this was a quick review on how to graph. Now, so again, right, one solution means consistent independent system. So now I want you to do it by substitution. Okay, and if you notice, I use the same equations. Yes, you know we're going to get the same answer because you can do when you solve, you can do it like in 3 or 4 different ways. So now, when you use substitution, you always ask yourself, which variable is isolated? For example, here the y is isolated, right? So that means that it's easier to use y equals to 3x minus 6, and we're going to plug in 3x minus 6 into equation number 2 for the y value. Okay? Since the y is isolated in equation 1, we're going to substitute 3x minus 6 for y in equation 2. That's what I just mentioned earlier. So it's going to go here, right? You see, so I left some space because I'm going to plug in 3x minus 6 for the y. And then all we do is just distribute. So we get 5x, -5x minus 6x plus 12 equals negative 10. Now I'm going to combine like terms, which these are considered like terms. So negative 5x minus 6 will give us negative 11x plus 12 equals negative 10. Now I'm going to move the 12 to the right side by subtracting 12 from both sides. Right, so negative 10 minus 12 will give us negative 22. Now I divide both sides by negative 11. And the answer is 2 because negative 22 divided by negative 11 will give us 2. So my x value is 2. Now I need to go back to either 1 or 2 and plug in the value for x, another equation, and solve for y. So here is where you have to decide what's easier for you. Okay? In my opinion, since the y is already isolated and we're solving for y, in my opinion, it's wiser to use equation 1. Okay, we know x equals 2, so I'm going to plug in the 2 right where the x is. So 2 goes in there. So 3 times 2 is 6. 6 minus 6 is 0. So that's my solution. X equals 2 and y equals 0. The solution is 2, 0. And again, this is consistent, independent system. Now, I'm going to do the very same one, but now I'm going to use the elimination method. Just so you see that every time you're solving for a system, you can use different methods. So you always use what the instructor tells you to use. But if the instructor doesn't mention what method to use, you use whatever is easier for you. Okay, for the elimination, both equations have to be in this form. The ax plus by equals c. Okay? So we need to rewrite number 1 in proper form. Number 2 is okay, but not number 1. So number 1, I have to write it in the ax plus by equals c form, which means that I'm going to subtract 3x to both sides. All right, so there it is now. You see, so now it's in the ax plus by equals c. So now this is equation 1, this is equation 2. Now here, it does not matter what you want to get rid of. You have to eliminate the x's or the y's. It's up to you. As for me, it's easier to eliminate the y's because this y is already by itself. So if I multiply by 2, right? Because 2 minus 2 will give me 0, but I need to multiply 2 times both sides of the equation. You see, so you need to eliminate x's or y's. Whatever is easier for you, eliminate the y's. That's what's easier for me. So I'm going to multiply both sides by 2 or every term by 2. It means the same thing. So 2 times negative 3x will give us negative 6x. 2 times y will give us positive 2y. And 2 times negative 6 will give us negative 12. And equation 2 stays how it is. Right? So I know these are going to be eliminated because 2 minus 2 is 0, but we have to add negative 6x minus 5x gives us negative 11x equals to negative 22. Now we divide both sides by negative 11. So we get x equals 2, just as before. Now the next step is the same step as what we did when we solved by graphing. I mean by substitution. Sorry about that. So again, need to find y value. We plug it into 2. I mean, plug in 2 for x in either 1 or 2. What's easier? So again, it's easy, right? Because this equation here, right? The equation 1 became this is the same equation, but this was just in the form ax plus by equals to c. So we can plug them in here on the original number 1. Then. You see, guys, we get the same value as before. So the solution is 2, 0. And again, it's consistent, independent. Okay, now guys, I'm going to do it the same thing, but instead I'm going to eliminate the x's. Okay, same thing. Just so you know, it's the same thing, but it's a little bit more work. Okay. So here we go. Okay, so instead of get rid of the y's, I'm going to get rid of the x's. Just so you know, it's a little bit more work. So to eliminate the x's, equation 1 must be multiplied by 5, and equation 2 must be multiplied by 3. I mean 1 negative. It doesn't matter which one. So negative 5 times 3 will give us positive 15. Right? 15x minus 5y equals 30. And this one I'm going to multiply by 3 because 3 times negative 5 will give me negative 15. So now we get negative 11y equals 0. We divide both sides by negative 11. So y equals 0. Now, again, we go back and try to solve for x now. So we go back to either 1 or 2. And this time, I believe it's easier to go to number 2 because we're solving for x, not for y. So we plug in the 0 for y. So we get negative 5x equals negative 10. We divide both sides by negative 5. So x equals 2. You see, so you get the same thing because at times, my students will ask me, "Hey, Mr. Isasi, what should I do?" They get confused because they don't know what to do. They try to follow some examples, and at times some of the examples are a little bit more tedious to work out. So that's why I tell them what's easier for you, okay? Because we all think different. Okay. Now here's another one. Okay, solve the system by elimination. Up to this point, they've been examples of one solution. Now I'm going to do an example of infinite solutions. Okay. So we're going to do it also by elimination. So by elimination, I'm going to multiply equation 1 by negative 2 because negative 2, right, will cancel my x's. So negative 6x plus 6x will give me 0, right? Everything will cancel if you notice. Remember, guys, I told you that a equals to a, right? And I said I would refer back to b. I think it was b that was infinite solution. So this means infinite solutions. So it's a consistent, but it's a dependent system. Now let's do an example of parallel lines, which means no solution. Again, here we're gonna get rid of again the x's, right? We multiply by negative 3. By negative 3 times every term. So we get negative 6x minus 15y equals to negative 24. And equation 2, we bring it down. So this is 0, but here we get negative 6. Does 0 equals to negative 6? No, it doesn't. So you can remember what I said, that there wasn't going to be no more variables, no x's, no y's. That's an example of either infinite solutions or no solution. In this case, since 0 does not equal to negative 6, no solution. It means that the lines are parallel. Okay, and it's called an inconsistent system. Now, what we've done so far apply like in real life. So this is an example how to apply this in real life. This is number 8. A 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $1,435, how many adults and how many children were in the audience? Okay. So here's my setup. Need to find two equations. So I'm going to do seats with seats and money with money. What does that mean? This means that that adult seats plus children seats must equal to 200 seats. And then the money means that well, let me do the first one. The first setup here. So we're going to let x equals to adults. We're going to let y equals to children. And there are 200 seats, right? So x plus y must equal 200, right? Because these are the seats. X adult seats plus y, which are children seats, equals to 200 seats. Now here comes money with money. Adults was $8, right? So this is going to be 8x. Okay? Because adult tickets are $8, so since adults is being represented by x, so it's going to be 8x. Children tickets are $5, right? So we said that y was children, so this is going to be 5y. And the total income was 1,435, right? So 1,435. So 8x plus 5y equals to 1,435. That's what I mean with money. And that's my equation. So this is equation number 1, equation number 2. Now here you can solve it any way you want, anyway. But in my opinion, when they're in this form, the ax plus by equals c form, it's easier to solve it by elimination method. So again, equation 1 and 2. So here it depends what you want to get rid of. This doesn't matter if you want to get rid of the x's or the y's because they're the same amount of work. So here I'm going to get rid of the x's. So I'll multiply equation 1 by negative 8 because negative 8 times x will give me negative 8, and then when I add it to 8x, you'll be eliminated. But I have to multiply negative 8 times every term. So this is what I get. Negative 8x minus 8y equals to negative 16. Now we add them, right? So the x's are eliminated, so we're left with negative 8y plus 3y equals to negative 3y. Negative 1600 plus 1435 will give us 165. We divide both sides by negative 3, so we get 55. Now I need to go back and plug in 55 for either equation 1 or 2 for the y, right? So it's easier to run number 1 because the x is already isolated. So I'm going to plug in 55 for y, subtract 55 to both sides. So x equals to 145. You see, 55 plus 145 are the 200 seats. So there's going to be, right, x was adults, so it's going to be 145 adults and 55 children in the audience. That's how you use systems of equations in real life. Now, these are larger systems of equations. For example, these are going to have 3 variables. I have a system, guys, that if you follow it, you cannot go wrong, okay? But let me explain first what we need to do. It's always wise for simplification to always have on equation 1 have a coefficient of 1 for the x if possible. See? Rearrange a possible coefficient of 1 on the x being equation 1. So here, guys, all I did was I switched 1 and 2. Equation 2 became number 1, and equation 1 became number 2. Okay, now, here's my plan. Okay, here's the plan. I'm going to get equation 1 and equation 2, and I'm going to get rid of the x's. Okay, and also equation 1 and 3. So I'm going to get 1 and 2, eliminate the x variable. After you do that, I'm going to get a new equation 2 and a new equation 3. Then I'm going to get the new equation 2 and the new equation 3 and get rid of the y's or eliminate the y value. After you do that, you're going to get something like z equals to a number. We're going to get the value for z. Okay? And let z be a real number. Okay, now, so that's my plan, okay? After all steps, it should look something. After I do all that steps for the system here, it should look something like this. You see, because here on equations, equations 2 or 3, it doesn't have no x's because on equation 1 and on 1 and 2 and 1 and 3, I eliminate the x's. So this might be equation 2 or equation 3, write a new one, but I just chose one. And at the end, you have something like z equals to a number, right? So, and let's see. Z equals to c, and c is a real number, and see my real number here is negative 1. Now I'm gonna back substitute, which means I'm gonna go to equation, the second equation. I'm gonna plug in negative 1 for z and solve for y, and then I'm gonna go back and place the values for y and z and solve for x, which I'm gonna show you right now. Okay, but let me show you how do we go from here to here. Okay, so here's my plan. We have equations 1, 2, and 3. So I'm going to get equations 1 and 2, right? So I'm going to do by the elimination method. So I have to cancel the x's, right? Or eliminate the x's. So I'm going to multiply this whole equation by negative 2. When we multiply negative 2 times x, we get negative 2x. Negative 2 times negative 3y will give us positive 3y. And negative 2 times 2z will give me negative 4z. Negative 2 times 0 will give me 0. And equation 2, we just bring it down. So, right, you see, so the x's are eliminated. So that's my new equation 2. Now I'm going to get equation 1 and 3 and repeat the process. Right, so now I'm going to multiply equation 1 by negative 3. So after you multiply equation 1 by negative 3, we get negative 3x plus 9y minus 6z equals to 0. And equation number 3, we just bring it down. So the x's are eliminated. So this is my new equation number 3. But I believe this was the one that was there that I used because the numbers are too kind of big. That's why I like to use the one with numbers are smaller, because it'll be easier to do some, to do the work. So now that was step one, right? Now step two, I'm gonna get equations 2 and 3, and I'm gonna eliminate the y's. Okay. So here I'm gonna multiply this one by -10 and this one by 4. Because at times they say multiply by the least common multiple, which is 20. But to me, I don't want for students to be looking for the least common multiple. For both of these. So instead, just multiply one by the other number. Since it's both positive, one has to be negative. But if you know that the least common multiple was 20, well, then you can use 20, right? If you do that, at the end, you don't have to simplify. So now I'm going to multiply -10 times every term on equation 2. We get -40y plus 30z equals to -30. And again, I'm going to multiply 4 times every term on equation 3. So we get 40y minus 28z equals to 28, right? The y's are going to be eliminated, so I'm left with 2z equals to -2. We divide both sides by -2, so we get 1, -1. Remember, guys, that I said it should look like that? There it is. I could have used, if I wanted to, I can use any equation here, 2 or 3 here for number 1. But since number 1, it's already there and the x is isolated, right? There's no coefficient. I like to keep it like that. And then between these two, right? Remember I said this was easier because the numbers are smaller. That's why I put that one as number 2. And then this is where we say z equals to c, right? So here we have z equals to -1. Now I'm going to go to equation number 2. So I'm going to plug in -1 where the z is. So 4y plus 3 equals 3. We subtract 3 to both sides. So we get 4y equals to 0. We divide by 4. So we know that y equals 0. Now I found the values for y and for z, but we should need to find them for x. So now I'm going to go to equation 1. But again, here, guys, you can go to either equation 1, 2, or 3. But in my opinion, again, 1 is easier because the x has no coefficient in front of it. Well, it has a 1, but we don't put the 1 there. So we're going to plug in 0 for y and -1 for z. We simplify, so we get x minus 2 equals 0. We add 2 to both sides, so we know x equals 2. So what's my solution? 2, 0, -1. That's my solution. That's where all 3 equations intersect. Okay? Okay, now. So that was number 9 there. So now, guys, this is very crucial, guys. This is called the Gauss-Jordan elimination method. If you take 1325 in chapter 7, when you're programming, you have to use, it's very, very similar to the Gauss-Jordan elimination method. So please try to understand this method, because you will be seeing it again if you happen to take 1325, if you're going for business or for accounting. Okay, here's my objective. This is called linear systems of equations, right? Which what we've been doing, we have to put it as an augmented matrix. And right now I'm going to show you what it means. After that, right, we get the solution by matrix of RREF. The RREF stands for reduced row echelon form. Okay, what does that mean? Okay, I'm going to show you right now what it means. This is the systems of equations, right? The one that we did earlier. Augmented means that I'm going to put it in matrix form, right? You see, if you notice, all I did was I got the coefficients for x is 1, y is -3, z is 2, and the constant over here is 0. You see, same thing. I just got the coefficients. So this means it's going to be in augmented form. Okay. So now, reduced echelon form means it's going to be in this form, right? Remember, these are my x's, these are my y's, these are my z's. So this one's already solved, right? It means that 1x plus 0y plus 0z equals 2, or just x equals 2. And row number 2 means 0x plus 1y plus 0z equals 0, or just, this is a y column, so y equals 0. And same thing over here, z equals to -1. Okay, now, how in the world are we going to do that? Okay. So I came up, or not that I came, yeah, well, I kind of modified it to a 3-step plan. And I have a story to share with you guys. Maybe one of these days, if we do when we go back to lecture, and if I have you as my student, I'll share how I came up with this modified method. Okay, now, so here, here I'm going to do it with math concepts and terms. For example, let all letters be real numbers, because every time that you use letters, you have to state what they are. So this can be any numbers, okay? This is already an augmented matrix. So I want to have it in reduced row echelon form, right? So I want to have it in this form, right? And again, this is x equals to whatever the value is there. X, y, and z will be also all real numbers. Okay, now this is step 1 here. Okay, this is called row 1, row 2, row 3. So step 1 is going to be in blue. You see, I like to color code stuff. You see, step 1 is in blue, step 2 is in green, and step 3 is in red. So I do it in 3 steps. If you follow the system, guys, how I'm going to show you here, you can never go wrong. Yeah, everything will fit like a glove. Okay. So my first step is that I need to make the E a 0. And my second step, I need to make the I a 0 by using the first row or the A, right? This is like the X. After you execute step 1, these are zeros, right? You see they're zeros, step 1. Now, step 2, for step 2, row 2 stays the same. Or you can know it or not, right? You see row 2 stays the same, and now this must be a 0, the B must be a 0, and the Q must be a 0, right? So after you execute step 2, you see there's zeros. You see this is step 1, step 2, and step 3 is going to be in red. So now step 3, if you notice, these have to be zeros here, the U in the end. So after you execute step 3, and I say to simplify if possible, as you do each step, this will guarantee that you finish it in 3 steps. You see it, there it is, and you're done. So now, for students that don't understand, because at times students get all confused with all those letters. They say, hey, Mr. Isasi, well, why too many letters? There's X, there's Y, there's Z, there's A, B, C, and all that. So for students to eliminate the confusion, this is what I do. I just put number signs. That way they know it's a number, right? And I'm going to repeat the same thing all over again. But instead of putting like the part of the alphabet, I just put the number signs. You see, this is step 1. These must be zeros here. After you execute step 1, right? There's zeros again. And step 2, these 2 must be zeros. So that's going to change, and that's going to change. That's why I put the arrows where the change is going to be. So after you execute step 2, right? So these are zeros. Now step 3, that's going to change to a 0, and that's going to change to a 0. So that's going to change, and that's going to change. So after you execute step 3, and again, you simplify if possible as you use step. So then these are my answers, right? So the answers over here, let me go back, previous. So whatever number is there, that's the answer. X equals to whatever number is there, Y equals to whatever number is there, and Z equals to whatever number is there. So this way, no student gets left behind, because at times, like I said earlier, with other letters, students might get confused, okay? So I don't want nobody to be confused in my class. Now, let's put the 3-step plan in action, okay? Okay, now, this is the same one as before, right? Remember when we solved this one with solving by linear systems of equations, when I said the plan was equation 1 and equation 2, get rid of the x's. So I got the same system, but now I'm going to do it by using a matrix, okay, the Gauss join method. Every slide, guys, is going to have a step, okay? This will be step 1, and then the next slide will be step 2, and then the third slide after this one will be step 3. And then we'll do an example, everything in one slide. So augmented, right? So we want to have it in reduced row echelon form. That's our goal, to have it in that form, and this is going to be my answers. So then, right, so row 1, row 2, and row 3. So here, guys, the 2 is going to be a 0, and the 3 is going to be a 0. This is step one. So on step one, we keep row one stays the same, okay? So now the 2 must be a 0, and right, so that's gonna change, and the 3 must be a 0, so this row has to change. So then we have to use row 1. That's why it's always wise to have a 1 for the coefficient on the x, right? Because it'll be easier to do it also this way. So I'm gonna multiply -2, right, times row 1 and add it to row 2. You see, there it is, because -2 times 1 will give me -2. Then when added to row 2, it'll be a 0. And here, guys, I'm going to multiply -3 times row 1 plus row 3. And here's my work. -2 row 1 is this part here. So I'm going to multiply -2 times 1 times -3 times 2 and times 0. And this is what I get. -2, 6, -4, 0. Now plus, here my row 2. My row 2 is 2, -2, 1, 3. Now when I add them, you see the first column it becomes a 0, right? So we have 4, -3, 3. And here, guys, this is going to be my new row 2. Now let's go to the next slide, right? Oh, no, I mean to the second step. My bad. I was jumping the gun here. So -3 row 1 will be -3 times row 1, which is going to be -3, 9, -6, and 0. Now I'm going to add it to row 3. Row 3, we'll just bring it over here, right? This whole thing right there, 3, 1, -1, 7. So after we do the addition there, we get 0, 10, -7, 10. 0, 10, -7, and 7. That's my new row 3. So this is step 1, guys. Now I'm going to go to step 2 on my next slide. Okay? Remember, this is where we left off, right? Step 1. Now step 2, step 2, we have to get rid of the -3 and the 10, right? Because these must be zeros, right, in green. That's why everything is color-coded. But before I start, step 1 was row 1 stays the same. Step 2, row 2 stays the same, right? Because I have to eliminate the -3 and the 10 by using row 2. So that's gonna be a 0, and that's gonna be a 0. So here, guys, I'm gonna multiply 3 times row 2 and multiply 4 times row 1, right? Because this way is gonna give me -12 and 12, and they'll cancel. You see, there it is. Here, I'm gonna multiply row 2 by -10 and row 3 by 4, right? So then here, this is what we do here, guys. I'm doing the step up here. 3 row 2 plus 4 row 1. So 3 row 2 equals to 3 times row 2. So 3 times 0 is 0. 3 times 4 is 12. 3 times -3 is -9. 3 times 3 is 9, right? Now plus 4 row 1. 4 times row 1. There's my 4, and there's my row 1 right there. So it's going to give us 4, -12, 8, and 0. So after I execute the operation there, it's going to give me 4, 0, -1, 9. So that's my new row 1. Now I repeat the process by trying to eliminate the 10 in row 3. Okay. So -10 row 2 is -10, right? There's my -10, and there's my row 2, which is 0, 4, -3, 3. So after I distribute, I get 0, -40, 30, and -30. Plus 4 row 3, right, is going to be 4 times row 3. There's my row 3, which is 0, 10, -7, and 7. So after I distribute, I get 0, 40, -28, and 28. So we get 0, 0, 2, and -2. Remember where I mentioned, guys, that you always simplify if possible. So here, guys, we can divide everything by 2 because I want 1 to be in the slot here. Right, so if you divide everything by 2, we get 0, 0, 1, -1. And that's my new row 3. Now for the next step, right? Now I'm one step short, right? So these two must be zeros now. So that's going to be step 3 on the next slide. Okay. So again, I left up here. So now I need to make these 2 zeros here. So remember the objective, step 3. Row 3 stays the same. So that's going to be a 0. and that's gonna be a 0, right? So that's why I put the arrows, because this is gonna change, and the arrows here because that one's gonna change for the -3 is. We're gonna use row 3. So to eliminate the 1 there, right, can we just add these, right? And they'll cancel, so it'll be row 3 plus row 1. To eliminate the -3, I need to multiply this row, right, the whole row by 3, because 3 times 1 is 3, right? And then when we add it, it'll be 0. And here's my work. So row 3 plus row 1, right? Row 3 plus row 1 gives us 4008. And again, we simplify as we go along. We divide everything by 4 because the objective was to make all these ones, right? So if you follow my method, guys, you cannot go wrong, and you eliminate all the fractions until the very end. So we divide everything by 4. So we get 1002. So that's my new row 1. So to eliminate the -3 in row 2, we multiply 3 times row 3, which will give us 0, 0, 3, -3, and we're going to add it to row 2. We get 0, 4, -3, 3, right? So it'll be 0, 4, 0, 0, 0. So remember, guys, this, we want it to be a 1 there, right? So we simplify, we divide everything by 4. So we're going to get 0, 1, 0, 0. That's my new row 2. So what's my solution? X is 2, Y is 0, and Z is -1. There you go. Okay, now guys, I know that I went a little bit fast, but I will, I will put my, I believe on the last PowerPoint that I did last week, I put my email there, my email address. You can email me, and I'll send you this slide, but it's not going to have no, it won't be recorded, right? It'll just be the PowerPoint. Not the slide, the PowerPoint, and you can go at your own time. At your own pace. Okay, and this way you can try to understand it better and then go step by step. Okay, because everything here uses animation. Okay, now let's work together. Okay, so here we go. So step 1, that has to be a 0. That has to be a 0. So this is going to change, right? Step 1 again, we use row 1, so it stays the same. So that's going to change, and that's going to change, right? So we're going to use row 1. So here we're going to do -2 row 1 plus row 2, right? Here, all I do is I can just add them, row 1 plus row 3, and then it'll give me a 0 there. And here, guys, I pointed here, guys, because my solution that I get is going to go in row 2 here. You see row 2, and here is going to go to row 3. And here's my work. Step 1, we have -2 row 1 is -2 times 1, 2, -1, and 6. So after we distribute, we get -2, -4, 2, and -12. Plus row 2, we just bring the row 2 down here, right? Row 2 is 2, -1, 3, and 2 is right there. So after we do the addition right there, so we get 0, -5, 5, and -10. And remember, guys, I said, can we simplify here? Yes, we can, because everything can be divided by -5 or by 5. Because if you leave it like that, if you don't simplify it, it's going to be harder. It's going to be more work. It's going to be a lot more work if you don't simplify it. So since I want this to be a 1, I'm going to divide everything by -5. Right, so 0 divided by -5 is 0. -5 divided by -5 is 1. 5 divided by -5 is -1. And -10 divided by -5 is +2. So that's my new row 2. So for to eliminate the x value on row 3, right? So it just be row 1, which is 1, 2, -1, 6, plus row 3. It's going to give you 0, 1, 0, 1. That's my new row 3. Now, hey guys, like I said, at times students, they're all confused because they'll be saying, but there's a 0 here, it has to be a 1. Like I said, don't worry about that, guys. Everything will fit like a glove. Everything will like I said, fit into place. Just follow my steps here, and you'll be done in 3 steps. Okay? So step 2. Step 2, right? Row 2 stays the same. That has to be a 0, so that's going to change. And that has to be a 0, that's going to change. Okay? We're going to use row 2. So I'm going to multiply -2, right? times 1, right? I mean times row 2. That way when I add it to row 1, they'll cancel. So we got negative 2 row 2 plus row 1. I believe this is the hardest thing for the students, but once they get all the practice, this will be easy, guys, because once you get this, all you do is just bring it down, right? Like for example, right here, all I did was bring it down here, and I did the operation, and then I do simplify, and you get the answer for that row. So and again, this will be always the hard part. So on this one here, okay, if I would have like a lot of students, joining, I would tell them to actually to participate. But since this PowerPoint is kind of long, right, and I have an hour, that's why I'm trying to go like at a steady pace. Okay, but this will be wonderful for instructors to use on an actual course because they can get the feedback from the students, and then they will move on until they get the right answer what to do here. But for time's sake, here, guys, I'm going to multiply this one by negative 1, right? Negative 1 times row 2 and add it to row 3. Okay, there it is. And now here's my work for the negative 2 row 2 plus row 1. So there's my negative 2, and this is my row 2, right? So after I distribute, I get 0, negative 2, 2, and negative 4, plus row 1. So we just bring row 1 down here. Right, that's my row 1, which is 1, 2, negative 1, 6. After we do the operation here, we get 1, 0, 1, 2. That's my new row 1. So here, guys, right, to eliminate the the 1 here, we're gonna is negative 1 row 2 plus row 3, and here's my work over here. There's my negative 1 row 2, so I'm going to distribute the negative 1. We get 0, negative 1, 1, and negative 2. And I got that by distributing the negative 1 times every term here. Plus row 3. So all we do is bring row 3 down here. So then we execute it. So we got 0, 0, 1, and 1, and negative 1. So that's my new row 3. You see, guys, like I said, do not kind of freak out because there's no 1 there. You see, there's my 1. After you do the operations, everything will fit in. Now, step 3. So step 3, we're going to use row 3, right? So row 3 is the same. That's going to change. So we're going to put an arrow there, and also that's going to change, right? So these two must be zeros. So if you keep simplifying, guys, like we did here, everything will be very, very simple numbers. But if you don't simplify it, like here on step 1, then there'll be tedious work there. Okay, so it's always good to simplify it. But by simplifying, I mean if you don't get a fraction. If you get a fraction, don't simplify it, leave it how it is. Because fractions is where students begin doing mistakes. Okay? So again here, I'm going to multiply negative 1 row 3 plus row 1. And I'm going to just add them, row 3 plus row 2. Okay, so here's my work. So I'm going to distribute negative 1 times every term there. So I'm going to get 0, 0, negative 1, 1 plus row 1. Right, so row 1 was 0, 0, 1, 2. We bring it down. We get 1, 0, 0, 3. So that's my new row 1. Repeat the process for the next step, right? So there's my row 3, plus row 2. We just bring the row 2 down. So we're going to get 0, 1, 0, 1. That's my new row 2. And guess what, guys? You see, there's my X, there's my Y, and there's my Z. There's my solutions. Okay. 3, 1, negative 1. And like I said, just follow this method, guys, and you cannot go wrong because most of the books, they do it like in 7 to 8, even 9 steps. Also, some instructors, they do the same thing because when I was taking this, when I was taking this course, the instructor would take too many matrices, like, and then there'll be too many pages, too much paper, and students will get kind of discouraged. But that's why I modified it in 3 easy steps. Okay. Now, how does that work in real life? As an example, tickets to a band concert cost $5 for adults, $3 for teenagers, and $2 for preteens. There were 570 people at the concert, and total ticket receipt were $1,950. 3/4 as many teenagers as preteens attended. How many adults? teenagers and preteens attended. So we're going to do something similar to the one that we had about the concert, right, with children and adults, similar to here. We need to find three equations now. Again, people with people and money with money. And then for the third equation, we just wait at the end. So people, right? So we have adults, teenagers, right, and preteens. So let's add equal to x, y, and z. Let x equal to adults, right, in order. Y equals to teenagers, and z equals to preteens. So there's a total of 570. So it's going to be x adult seats plus y teenager seats plus z preteen seats equals to 570. There's equation number one. Now money with money, right? So adults cost $5. So this will be 5x, right? Teenagers cost $3, so that's going to be 3y. Preteens cost $2 for the ticket, so that's going to be 2z. And how much was the money total? 1950. So receipt was 1950. So we're going to add 5x plus 3y plus 2z equals to 1950. That's equation number two. Right, so we have one and two. This is the most difficult one of all. Okay. Right, so I'm going to use this for the third one. Okay, now. Okay, it says, right, they're talking about teenagers and preteens. Here's where a lot of students get confused. It says 3/4 as many teenagers as preteens attended. So this is what it should be. Y equals to 3/4z. Okay, but this is kind of hard to understand, right? I mean, why is it like that? Because it sounds like 3/4 y, right? Because y are teenagers equals to z. So you know what? Just set it up that way. If it's difficult, write it how it sounds and then flip it. What does it mean by flip it? Here's an example, right? So it sounds like this, right? 3/4 as many teenagers, right? Teenager is y, so 3/4 y equals to preteens equals to z. Now just send the 3/4 over here, right? You flip it. Maybe that's a wrong word to say, but what I mean by flip it, just flip the 3/4 on the other side, or just send it to the other side, and that's my setup. Okay, but now you don't want no fractions, right? So here I'm going to multiply everything by 4. Multiply both sides by 4. So we got 4y equals 3z. Now I'm going to subtract 3z to both sides and have it like ax plus by plus cz equals to d, right? Like a constant over here. And that's equation number 3. So there's my setup, guys. Now you get to try it, right? You get to try it either by the method that I just showed you, which was by Gauss Jordan, or you can use equation 1, equation 2, and so forth, like I showed you earlier, guys, right? So, and this should be the answer. So you try it at your own time. Okay. Now, I believe in the spring semester, they if you watch the video, right, you can get credit if you didn't attend. So I believe maybe Ms. Patricia or Ms. Shuka can put the link here so you guys can be able to answer this question and perhaps get credit for attending if you didn't have time to show up today, guys. Okay. Well, that's it with this presentation, and hopefully it was beneficial. Okay. Let me stop sharing my screen now. Okay, let me stop sharing. So, any questions? Anybody?
Alrighty. Thank you so much to Mr. Isasi for presenting today. Thank you to the audience for coming and being a wonderful audience as well. We hope you have a wonderful summer semester and know that online tutoring is going to be open and here for you. Uh, I'll go ahead and share the next week's virtual events so that you guys are aware of which ones may occur. So for next week, we will be having the 1324 review session on a Tuesday at 3 p.m. still. So that's a little change. And then the 1314 will be Friday as regularly scheduled. So the 1324 will cover as shown in the flyer here. And then the 1314 will cover synthetic division and finding zeros. So yeah, I hope to get I see you guys next week.